This is the atomic theory timeline. Okay. So the Greek model, which is from Democritus, a Greek philosopher, began a search for a description of matter during 400 BC. He wondered if matter could be divided into smaller pieces or if there was a limit to the number of times a piece of matter could be divided. Then came his theory that matter can't be divided into smaller pieces. And the smallest piece of matter was called atomos, meaning that it can't be cut. Then came the name atoms, which we use now. And also in the theory was that atoms were small hard particles made of the same material but were different sizes and shapes. He also said that atoms were always infinite in number and atoms always move and join together. But his theory ended up being ignored. The Dalton's model. Okay. So in the early 1800s, English chemist John Dalton, he performed lots of experiments that eventually led to the acceptance of the idea of atoms. He said that all elements are composed of atoms. And atoms are indivisible and indestructible particles. Atoms from the same element are the same, and atoms of different elements are different. Compounds are formed by two or more atoms joining. The plum pudding model. This is from J.J. Thomson, who was an English scientist in 1897. He discovered that an atom was made of smaller particles. He then created the plum pudding model. He said that atoms were made from a positively charged substance with negative charged electrons, and they scattered around like raisins in a pudding. And the name came from a British snack that was really favored there. So that's how they got the name of plum pudding. Okay, so Thomson's experiment was that he studied a passage of an electric current through gas. He noticed that as the current passed through the gas, it gave off rays of negatively charged particles. He then found out that they came from within the model, the atom. Then his conclusion led him to that an atom was divisible. They were made up of smaller particles, and the negatively charged particles called I really can't say this word. I apologize. Corpuscles. Interesting word. Is now known as electrons. And that since the gas in the tube was uncharged, there must be a positively charged particle inside the atom. But he could never find them. The Rutherford model. So before the model, he did a gold foil experiment. An English physicist, Ernst Rutherford, in 1908, made an experiment. So what he did was he fired a stream of tiny positively charged particles out from that lead block shield into the gold foil. And it was said that it was 2,000 atoms thick. So what happened was that bullets passed through the gold foil, and they were positive. If they deflected the foil, then they were negative. And I'm really sorry, that picture's not the best, but I think you could kind of get the idea. And that led him to the conclusion of positive charges repelling positive charges. and that atoms had small, dense, positively charged center called the nucleus, and the nucleus repelled positively charged particles. He also said that the nucleus is tiny and that negatively charged particles were scattered around the nucleus, and the positive right there is the nucleus. Next, the Bohr model. So in 1913, a Danish scientist, Niels Bohr, placed each electron in a specific energy level. So unlike Rutherford's, there's orbits, and the electrons are in specific spots, unlike the Rutherfords, where it's just scattered around everywhere. So yeah, that's pretty cool. His theory was that electrons move in definite orbits around the nucleus. He said that these orbits are located at certain distances from the nucleus. So that might be like 2 feet. That might be another 2 feet. You could tell the distance from there. And lastly, the wave model, where electrons don't move in a definite path, and it's impossible to determine the exact location of the electron. Also, electrons whirl around the nucleus billions of times in 1 second. That's pretty crazy. That's really fast. That's really fast. And that they move around in a certain pattern in the electron cloud based on the energy level. So electrons with the lowest energy are found in the energy level closest to the nucleus, and that electrons with the highest energy are found in the outermost energy levels, which is obviously farther from the nucleus. And there's the picture. So that is the end of the video. Thank you. See you next time.